Here we have an Asus laptop that came in for no power. I disassembled the board, and I had to do it because, as you all know, Big Boss is gone for 1 month and he's not here to disassemble the laptop in 2 minutes. It took me 15 minutes to take out all the screws and all the bits and pieces. It's always Big Boss's job to take stuff apart, but the board is out and we're gonna check and see why the board is not powering on. Let's start with the DC MOSFETs. We're gonna go to the DC area of the motherboard. And when I say DC area, I mean where you plug the charging cable. And if we go here, I want to check to see if we have a short on the drain of this MOSFET. And we have a short on the drain of the MOSFET. How did you know that you had to measure the drain of this MOSFET to check for a short? Because that's what I do every day. Work on Asus laptops, work on Asus laptops, work on Asus laptops. At some point, you will detect a pattern on what's wrong with them. And right now, what I want to do is inject voltage at the drain of the MOSFET, where the short is, and we're going to monitor the board under a thermal camera and see what gets hot. I have a feeling like this one is going to be a quick fix, but quick fix or no quick fix, we're still charging the customer the same price. Because experience pays. We do not charge the customer more for our experience, but rather we take less time to work on a device, and that's where experience pays. It used to be when I did not have much business when I started, I used to spend hours and hours working on one motherboard. But I came to a point where that's not the case anymore. And right now, if we go under the thermal camera, take a closer look. See it? One more time. I took the probe off and the heat spot disappeared. But look at when I put the probe on the shorted area of the MOSFET, the drain. Inject voltage here. And look at that heat spot right there. You see it? And this one is the second MOSFET from the right. So right now we have one of the two options. We know that the MOSFET is what's causing the short circuit. Either replacing the MOSFET will fix the laptop, or replacing that MOSFET is not going to fix the laptop. And the reason is, if the MOSFET let a higher voltage go to the CPU than what the CPU can handle, then our CPU is fried. And we're not going to be able to turn the laptop on. So let's go ahead and remove the MOSFET, and we're going to check to see if we still have a short. If not, we're going to replace it and hope for the best. Now, since we have Kapton tape here, maybe I'll take the time to explain the dangers of using Kapton tape. You could see that by applying heat, Kapton tape was starting to deform and change shape. What's going to happen is, once solder on the board reaches melting temperature and Kapton tape is deforming or changing shape, Kapton tape is going to force or is going to shift components under it. So after we're done with desoldering the MOSFET, we pull up the Kapton tape and we will notice that all those capacitors are shifted and they are out of place. Just imagine you have 20, 30 components under that Kapton tape, 1005 size components or 201 size components, and then you pull Kapton tape out and you notice all of them are just connecting as one piece or shifted from their place. I never ever use it unless I have to. In this case, because we are heating up the board to remove the MOSFET, I will just remove Kapton tape from here, so we do not cause any disturbance to those components. Now, if we did cause disturbance to those components, they're pretty easy to put back in because they are big, but just imagine you have tiny components, tiny 1005 size components, or 201 or even 402. You know what, let me just remove the whole tape. I pulled it to the side, but maybe we just need to remove the whole thing. And now we can work safely on the board. Because I see many times viewers, they post comments and they're telling me to cover the area with Kapton tape. Lack of knowledge. And now we came to a scenario where I showed you why Kapton tape is not good to use. Just avoid it when you can. It does block heat, but the board itself will get hot and solder will liquefy even if you have Kapton tape. I'm applying heat here. The board is getting saturated with heat, and heat is going to spread, and it will start to liquefy solder all over. By removing this MOSFET, maybe if I knock this one will come off because solder liquefied on this component as well. You cannot just expose one component to heat. The whole board is being exposed to heat, so that when it reaches melting temperature of solder, that's when you will be able to remove that component. Now that the component is out, let's see, do we still have a short? Let's go right here, and we're gonna check to see if we still have a short. I'm almost positive that that's what's causing the short, but let's go ahead and test. The short is gone. We're gonna replace the MOSFET and hope for the best. After replacing the MOSFET, I'm just gonna lock up and close the laptop, and we'll test it together. I cannot say today that I'm gonna give this to Big Boss to reassemble and test, because I have to do it on my own. We just increased the price on expedited service to $95 compared to $45. I do not want people to choose expedited. At $49, everybody was choosing expedited, and I cannot handle everything expedited. And the wait time, if expedited is not chosen, is 4 to 8 weeks. So customers know that they're gonna have to wait 4 to 8 weeks for their device to be fixed. And if expedited is chosen, then it will be 1 to 8 days. And just look at the details on this scope, the NorthridgeFix version 2 microscope, and compare it with version 1 working on a similar issue. You're gonna see a lot more details on this scope here. Even though version 1 was awesome, this one is even better because of the higher dynamic range. Bigger sensor. If you have not already purchased one, you can log into NorthridgeFix and buy it. You can buy the ring light as a separate item, and the stand, the articulating arm, for the time being, you can get it from Amscope. I left a link on the product description on our site. We are planning to carry those articulating arms, but we are still making a deal with the factory. The item is heavy and it costs a lot to ship. So it has to make sense for us to carry that stand. C09B. And I have a donor board here that we can extract that MOSFET from. C09B right here. Let's use this one. And we're gonna go back to the customer's board, and drain should be on the bottom, just like that. Now we're gonna press and hold. And we're done. Better than factory soldering. Look at the difference between the factory one, the soldering on the factory one, and look at ours. Hard to tell the difference. Except for that squeezed solder blob, which makes our MOSFET unique, right? Uniqueness is what we are looking for. Don't be a copy, be unique. Let's go ahead and measure again to make sure that we no longer have a short before I reassemble. Meter in diode mode. Awesome. We do not have a short. And let's consider this board fixed. So I'm gonna take a few minutes, few hours, few days to reassemble this, and I'll be back. All right, so I reassembled the laptop, and I already tried the laptop, but I want to finish the video to show you that the laptop did not work. Let's press the power button, and of course it's not gonna work, but I still want to show it to you. You see? Laptop is working. Just kidding. It's doing some type of hard drive repair. Maybe the computer was shut down without doing the proper shutdown, but that's irrelevant. Power is fixed, and that's it. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.